Cloud storage providers have been selling you a lie. Think about it. If remote cloud storage was truly the answer, why do our devices keep coming out with bigger local drives year after year? Today, I'm going to show you how I built my own private cloud using some of the latest tech, and it completely changed the way I manage my data. Yes, setting up your own cloud can be pricey up front, but over time, it begins to pay for itself. No more monthly subscription fees, and no more worrying about someone else having access to your private data. Sure, you could get by with an ever-growing collection of removable SSDs, but who wants to deal with the hassle of hubs and worn-out ports? Plus, external SSDs aren't cheap either. My 2TB Samsung T7 set me back $170. But my private cloud setup is not just cleaner, it actually outperforms SSDs, something I didn't even think was possible until I tried it. In fact, it's the only NAS I've come across that supports Thunderbolt 4, and trust me, that makes a huge difference. Plus, by putting the storage on my network, everyone in my household has access, and I can even securely reach my files remotely while traveling, which is a big quality of life improvement over my external drives. However, for my workflow, which consists of editing 4K videos for this channel, I needed a solution that could handle that heavy lifting without breaking a sweat. So just to prove a point, I actually edited this entire video on the ZimaCube's drives, and I'll talk about how that worked out for me. But here's where things get really interesting. What happens when we throw AI into the mix? Well, it turns out we can extend our device with Coral Edge accelerators for lightning fast facial recognition on your security cameras, or use private GPT to create an AI assistant that knows your documents better than you do, all without sending a single byte online. Let's crack into it. Quick heads up, today's video is brought to you by the awesome folks at IceWhale. They sent over this shiny new ZimaCube Pro for me to check out, and I gotta say I'm pretty stoked. We'll be using it for today's demo, but don't worry, everything that we talk about can be done with other DIY setups too. You can even start small with just an NVMe on a single board computer. Alright, so what the heck is this thing anyway? It's basically a standalone storage powerhouse with a motherboard, expansion ports, and enough drives to make your old external SSDs jealous. It connects to your network as a NAS, but when you want direct speed, it transforms into a DAS, direct attached storage, by plugging right into your computer. I'm going to focus on how I use this guy in my workflow without putting you to sleep. If you want the full tech teardown with all the painstaking details, there are other videos out there that dive into those nitty-gritty specs. Let's start with the unboxing. This device comes to us from IceWhale, a tech company based in China, and they've got some serious backing too. Funded by Miracle Plus, which you might recognize as the artist formerly known as Y Combinator China. Fun fact, that is the same seed fund that was once run by Sam Altman, who's now the CEO of OpenAI. So yeah, these folks definitely know their stuff when it comes to building high performance gear. This device comes in two flavors, the ZimaCube and the ZimaCube Pro. And the main differences have to do with CPU power, memory capacity, the 10 gigabit Ethernet NIC, and the Thunderbolt 4 port. Now, the Pro model is definitely on the pricier side, but let's be honest, anything having to do with 10 gigabit Ethernet and Thunderbolt is gonna cost you. But don't let that intimidate you. You can still try out these concepts by using single board computers and external drives you've probably got lying around. Then if you like the setup, you can treat yourself to an upgrade. The build quality on this thing, it's solid. We're talking anodized metal housing that feels like it could survive a minor apocalypse. And for those who like a bit of flair, it even has a quick LED light strip around the front. It's got 6 bays for HDDs that pop open like this. Super easy to access. But the real fun is the 7th bay, and that's where the magic happens, with M.2 slots for blazing fast NVMe drives. Personally, I love this because it means I can take this 970 EVO NVMe and get some pretty ridiculous speeds. With over 30 ports, this thing is just asking to be extended and customized. And get this, the 7th bay even has an ESP32 wired up to control that LED strip. Yep, you can control the lights with your phone because why not? Alright, let's add some storage. First, I grabbed a Seagate BarraCuda 2TB HDD for $65. Just pop out one of the bays, screw it in, and you're good to go. Next up, I grabbed a Samsung 970 EVO 1TB NVMe for $98. Installing it is as simple as slotting it in the 7th bay at a 45-degree angle and securing it with some standoffs. And if you're feeling adventurous, you can even use the PCIe port to add some local AI acceleration, perfect for future computer vision tasks or whatever fun projects you want to run. Next up, let's connect this guy directly to our router and fire it up. With all the storage plugged in, we power it on and it should pop up under the network under the hostname zimacube.local. This guy runs Zima OS, which is super smooth. We can even enable SSH and log in over Warp, which I always like to have handy for remote access. Adding new drives is dead simple because they automatically get detected and it prompts you to name and initialize them, and then you're ready to go. Sharing folders is straightforward too. To access them from other devices, just open Finder, hit Command K, enter the hostname, and boom, there's your shared storage. One of the coolest things about this setup is the ability to access my drives remotely, even when I'm nowhere near home. Now, there are plenty of ways to achieve this, from mesh nets to setting up complex tunnels, but I wanted something straightforward, so I configured a simple VPN on my Ubiquiti router, connected it through my phone, and just like that, I was in. Once the VPN was live, I could address my ZimaCube by its local IP as if I was still on my home network. It felt seamless. From there, I logged into the dashboard and navigated around effortlessly. But here's where it gets even better. Not only can you access the dashboard, you can use any application on the ZimaCube too. For example, I launched my local AI setup with Ollama and interacted with my Gemma model as if I were sitting right at my desk. This opens up a ton of possibilities. If you have a home media setup like Plex, you could easily access all your shows and movies on the go. And trust me, that's exactly what I plan to do as I expand this setup. All right, let's get into some benchmarks to see how this thing actually performs. I've lined up a few different device configurations to test. Before diving into the full benchmarking of the entire NAS setup, I wanted to first see how the base speeds of my drives performed directly on the ZimaCube. It's always good to get a baseline before adding in network layers. So I logged into the ZimaCube via Warp and ran some DD tests on both the NVMe and the HDD to get an idea of their raw performance. This comparison shows just how much faster the NVMe is compared to traditional HDD. But BarraCuda still performs decently, especially for a mechanical drive. These baseline numbers set the stage for testing how everything works together in a full NAS environment. Okay, so I want to run you through a bit more of a realistic example. In the upper left-hand side here, this is my local drive, and I have all my videos broken out into different files here, and there's this one folder, 60.7 gigs. And just to give you a sense of what's in this folder, we have lots of MP4 files, probably some audio files, various documents. If we go into thumbnails though, we have a number of different JPEG files. So a lot of files, some big, some small, and a good kind of diversity of data there. And what I'm gonna do is I'm just gonna drag it onto the drives that I want to test. We have the NVMe, which is part of the ZimaCube. That's the EVO 970. We have the BarraCuda HDD, which is also part of the ZimaCube. And then just for an additional data point, we have a mounted external drive, a Samsung T7 SSD. When I drag the folder into these different directories to copy it, I want you to be aware of, pay attention to the estimated length of time needed to complete that task, because that will give us a good sense. And we can also kind of just visually eyeball how fast it is. So I'm going to take this big directory here, this 60.7 gig directory, I'm going to copy it. Why don't we start with the external Samsung SSD? So I'm going to go ahead and paste that. Okay, so it initially clocks us in at a 3-minute duration to get the entire directory copied. We can see it's going pretty quick there, 6 gigs, 7 gigs. And again, this is a Samsung T7 SSD. Should have something like 400, 500 megabyte per second transfer times. All right, so let's do the same thing with the HDD. So this is the BarraCuda installed on the ZimaCube. Let's go ahead and paste that. Okay, so it's still saying 3 minutes. So these two seem to be pretty comparable. Yeah, you can see it chugging along pretty quick right there. All right, so let's try the NVMe on the ZimaCube. Okay, so again, I'm gonna take a 60.7 gigabyte directory and move it onto the ZimaCube from my MacBook, and we'll see how long it takes. Okay, so it started at about a minute, and you can see this one far and away is the fastest drive, and those transfer speeds are the fastest here. So an NVMe on the ZimaCube is pretty unparalleled. I mean, those speeds are pretty crazy. I do want to show you something else though. Okay, so this is the Zima control panel, and there's this interesting widget down here that shows the network activity, and it shows you the upload and download time. So this is another way to see how much data is passing to or from the ZimaCube. So right now there's basically nothing, it's idle basically, but let's go ahead and take this. I'm I'm gonna go ahead and delete that. And I'm gonna do another transfer, right? So I'm gonna grab this and I'm gonna start pasting it into here. And we should see this pick up here. So let's see, 300, okay, so 1 GB per second download, right? Because from the ZimaCube's perspective, it's downloading data. There's a couple different components here, right? There's the transfer speed, the network speed, but then there's also like the write speed. But we see the data coming in here at about 1 gig a second, which is quite good. And the reason I'm a little reticent to use something like Blackmagic speed test is because I was getting read-write times that exceeded what the hardware is even capable of. So I think there's some sort of issue with like maybe caching, or because it's a network drive, it's just misreporting. Like here, let me just give you an example here. So if we do 1 GB, let's start by doing my local drive, right? So my MacBook's pretty good. The read-write times are gonna be pretty fast. Yeah, so we're gonna get up to 4, 5, 6 gigabytes a second, which is quite fast. And obviously, again, this is like, CPU is like hardwired to these fast MacBook drives. So we would expect that. So that's fine. I can take that at face value. But if we go to like the HDD drive on the ZimaCube, this is a BarraCuda mechanical drive. It should be getting something like 200 megabytes per second, but it's reporting almost 1,000 megabytes per second. So I don't know if that has to do with caching. I'm not exactly sure what's going on with that. I would say that's probably not accurate. For everyday uses like editing in Adobe Premiere, streaming via Plex, running Home Assistant, or simply navigating files in Finder, it's a massive time saver. As a bonus, my partner also edits videos for this channel, and sharing files between us is a breeze. I just use Command K in Finder to instantly access the ZimaCube shared folder. It's really that easy. Lastly, we take a look at the power draw because performance is great, but efficiency matters too. Now, I didn't go too wild with the AI experiments, but I did install a dual edge TPU directly into the motherboard. The OS recognized the chips right away, meaning I could easily integrate this setup with Home Assistant and Frigate for some neat computer vision tasks. I also ran a quick test using Ollama to index a large directory of files, and the result was I was able to search and even chat with my documents pretty seamlessly, which opens up some pretty cool possibilities for managing data locally with AI. Okay, so I downloaded the Ollama UI application. It's running in a Docker container. Everything was very seamless. I went with the M.2 lightweight model. If you want better performance, you can use some bigger models, but this should be adequate here. But one of the interesting things of note here is this implementation of large language models utilizes RAG, which stands for Retrieve, Augment, Generate. So if we go over to the admin panel here, you can actually enable a couple additional features. One is web search. Right? So when the model's generated, it does become outdated, but with web search, it's able to fetch data, be more informed and be more accurate, and then bake that into the responses. Additionally, you can reference your own local documents. And so they set up this directory here where you can provide documents. And this is invaluable for any sort of like research project where you're kind of compiling a number of documents. I can see a lawsuit. This could be helpful if you have like all the docket records and the motions and you're mixing up the dates and that sort of thing. To create a model based on a directory where all those files are housed, I mean, you could literally just pose questions and get responses in seconds, which is pretty useful and saves you a bunch of time. But let's just do a very basic example here. So I'm going to do a new chat. I'm going to select M.2. Say I was interested in researching a cryptocurrency. I could grab the white paper, but maybe I don't want to read the whole thing. So I can go ahead and download this, and then I can call on it in my conversation here. So I'll just upload the white paper, and I can say, what is the most compelling concept in this white paper? And again, this is all running locally on the ZimaCube.
The most compelling concept in this white paper is likely the Stellar Consensus Protocol, SCP, and how it creates certainty, safety, and control for central banks. It uses a combination of consensus protocols and a mathematical analogy to achieve these benefits by creating a permission system that's connected to a permissionless network. The white paper explains this in detail using a case study on CBDCs to show the practical application of SCP.
So that's pretty neat and opens up a lot of potential. I mean, you could have all your local documents indexed by the LLM and not have to search. You could just ask the LLM for the answers or say, show me where this file is or where this document is. So I could see this getting quite a bit of traction. I was really impressed with the Thunderbolt connection for accessing my files and editing this entire video. It handled everything like a pro. That said, being the speed junkie that I am, I'm already thinking about a couple of optimizations to push the performance even further. First, I could take advantage of the 10 gigabyte Ethernet NIC on the ZimaCube and hook it directly into my router. Unfortunately, my current Ubiquiti UniFi Express only has a 1 gigabyte Ethernet NIC, which would bottleneck the speed. So I plan to upgrade to a router with a 10 gigabyte NIC, which will turn this ZimaCube into an absolute network attached storage beast with crazy fast data pipes. Another optimization I'm curious about is the Thunderbolt connection. Right now it's running through Samba, which is great for networking, but I think a direct mount protocol might be even faster. I'll probably give that a try next to see how much more speed I can squeeze out. Now, if the ZimaCube Pro seems a bit overkill or pricey for your needs, no worries, there are plenty of scaled down versions you can play around with, like throwing an NVMe on a Raspberry Pi or even a ZimaBlade. These setups can give you a few extra terabytes of network storage, but just know they won't match the throughput and performance of what the ZimaCube Pro can do. That said, it's always smart to have a backup strategy. While a private NAS is fantastic for speed and control, critical files like private keys, legal documents, or other irreplaceable data are still safer in cloud storage for disaster recovery. You could host those important files in the cloud while using your NAS for everything else, getting the best of both worlds. And real quick, guys, I'm pretty much done with the video now, and I can safely say that I noticed literally no difference editing this video on the ZimaCube directly versus editing where I normally do on my MacBook's internal drives, which are technically much faster. But that just goes to show that it can handily take on 4K video editing. And I also did a mix of the Thunderbolt connection, and then sometimes I pulled out the Thunderbolt and then I just relied on the LAN connection, and I still didn't notice a difference. No latency, no choppiness, playback was smooth. So this is going to be my new workflow just because there's more space on my private cloud. To stay ahead of the tech curve, check out this next video. Thanks.